Antarctica today is the coldest, driest and highest continent on Earth, a vast and seemingly lifeless desert of ice. It is a place of brutal extremes, where temperatures can plummet to unimaginable lows and the landscape is scoured by relentless winds. The thought of any large animal thriving here seems impossible. Yet this continent holds a deep secret, frozen in time beneath miles of ice, a secret from a past when it was not a polar wasteland. During the Mesozoic era, the age of dinosaurs, Antarctica was a world away from what we know now. It was a key part of the southern supercontinent, Gondwana, and was positioned much farther north. Instead of an ice cap, it was covered in lush, temperate rainforests. Ferns, cycads and towering conifers flourished under a sun that, while seasonal, provided enough energy to support a complex and vibrant ecosystem teeming with life. But this ancient world still presented a unique and formidable challenge: the polar night. For several months, each year the continent would be plunged into continuous near-total darkness. This created an environment unlike any other on Earth, forcing life to adapt to long periods without sunlight and the accompanying drop in temperatures. It raises a profound question: what kinds of dinosaurs could survive and even thrive under such demanding conditions? The very idea of polar dinosaurs was once considered fringe science. The immense logistical and physical challenges of conducting paleontological fieldwork in the most hostile environment on the planet meant that Antarctica's fossil record remained almost entirely unknown for decades. Scientists had to brave sub-zero temperatures and catastrophic winds, searching for small windows of opportunity when the rocks and their secrets were exposed. It was in these brief, precious moments that the first clues began to emerge from the frozen rock. These initial finds were more than just bones. They were fragments of a lost narrative, evidence that dinosaurs had conquered even the planet's extremes. These discoveries would not only introduce us to new species, but would fundamentally reshape our understanding of what it meant to be a dinosaur, starting with a predator that wore a frozen crown. In the austral summer of 1991, paleontologist William Hammer was excavating on the slopes of Mount Kirkpatrick, nearly 13,000 feet above sea level. His team was battling extreme cold and thin air when they uncovered the fossilized remains of a creature that would rewrite the prehistory of the continent. It was a large theropod, a meat-eating dinosaur, and the first of its kind ever to be named from Antarctica. This remarkable creature was named Cryolophosaurus ellioti, meaning frozen crested lizard. It was a formidable predator, measuring approximately 21 feet in length and weighing around 1,000 pounds. But its most stunning feature was a unique, delicate crest of bone that ran across its skull, just above the eyes. Unlike the crests of other dinosaurs like Dilophosaurus, this one was oriented forwards, like a bizarre pompadour. The function of this elaborate crest remains a subject of scientific debate and fascination. It was too fragile for combat, so it was almost certainly a display structure. It could have been brightly colored to attract mates or used in ritualized displays to intimidate rivals, a vibrant signal in the dim light of the polar forests. This crest makes Cryolophosaurus one of an elite group of dinosaurs whose headgear was a defining and mysterious characteristic. As the apex predator of early Jurassic Antarctica, Cryolophosaurus would have hunted the other animals that shared its unique polar environment. Its discovery was a landmark moment, confirming that large active predators could sustain themselves through the challenges of the long, dark winters. It was one of the largest known theropods of its time anywhere in the world, proving Antarctica was no evolutionary backwater for dinosaurs. The existence of Cryolophosaurus shattered the outdated perception of dinosaurs as slow-moving, cold-blooded reptiles confined to tropical swamps. It was powerful evidence that these animals were dynamic, adaptable, and had successfully colonized every continent on Earth, including its most extreme southern reaches. However, a large predator needs a steady supply of large prey, and another discovery nearby would soon reveal who was on the menu. Not far from where the remains of Cryolophosaurus were unearthed on Mount Kirkpatrick, another significant find was made, adding a crucial piece to the puzzle of Antarctica's Jurassic ecosystem. This new discovery was a large plant-eating dinosaur, proving that the continent's top predator was not alone. It was given the fitting name Glacialisaurus hammeri, the frozen lizard of Hammer, in honor of its discoverer. Glacialisaurus belonged to a group called the sauropodomorphs, which were the early relatives of the colossal long-necked sauropods like Brachiosaurus and Diplodocus. While not as gigantic as its later cousins, Glacialisaurus was still an impressive animal, estimated to be about 25 feet long and weighing several tons. It was a true giant of the early Jurassic Antarctic landscape, a formidable herbivore built for power and endurance. Its diet would have consisted of the rich flora that grew in the temperate Antarctic forests of the time. Using its long neck, it likely browsed on ferns, seed plants, and the leaves of coniferous trees. The presence of such a large herbivore is a clear indicator that the polar vegetation was abundant and nutritious enough to support massive animals, even with the challenge of a long, dark winter season when plant growth would have slowed or stopped. This raises fascinating questions about its survival strategies. Did Glacialisaurus migrate to other parts of Gondwana during the darkest months to follow the food supply, or did it have adaptations to cope with the lean times, perhaps building up fat reserves or subsisting on tougher vegetation like bark and twigs? The answer remains a mystery, but its ability to survive here speaks to the incredible resilience of these dinosaurs. The discovery of Glacialisaurus was critically important because it established a more complete food web. It provided the ecological context for Cryolophosaurus, confirming that a large prey animal existed to sustain the apex predator. Together, these two dinosaurs paint a picture of a dynamic and functioning ecosystem, a complex world that would continue to evolve as Antarctica slowly drifted towards its final, frozen destination at the South Pole. As we move forward in time by over 100 million years to the late Cretaceous period, we find an Antarctica that has changed dramatically. The continent had drifted further south, and while it still lacked a permanent ice sheet, the global climate was cooling. The world was becoming a harsher place, and the dinosaurs that lived there had to be tougher and more resilient than ever before. It was in this changing world that our next dinosaur lived. Appropriately, the very first dinosaur fossil ever discovered on the continent was one of these hardy survivors. Found in 1986 on James Ross Island by Argentinian geologists, it was an armored dinosaur named Antarctopelta oliveroi, which means Antarctic shield. This creature was a type of ankylosaur, a group of herbivores famous for their incredible defensive capabilities, often described as the living tanks of the dinosaur world. Antarctopelta was relatively small for an ankylosaur, measuring around 13 feet long. Its body was low to the ground and covered in an extensive mosaic of bony plates, known as osteoderms, embedded in its skin. It also likely possessed larger spikes projecting from its sides and shoulders, providing a formidable defense against any predator foolish enough to attack it. This armor was not just for show. It was essential for survival. As a low-browsing herbivore, it would have fed on the ferns and flowering plants that grew close to the ground in the cool Cretaceous forests. Its armored, robust body was a perfect adaptation for a life of steady foraging in a world with ever-present danger. Its very existence proves that even as Antarctica grew colder and more challenging, a diverse array of specialized plant-eating dinosaurs continued to call it home. The ongoing search for creatures like Antarctopelta relies on dedicated researchers braving extreme conditions. If you find these stories of paleontological adventure and the lost worlds of the dinosaurs compelling, please consider subscribing to our channel and leaving a like on this video. Your support is crucial in helping us continue to share these incredible scientific journeys. Now the question remains, what kind of predator would dare to take on this armored fortress? While giants like Cryolophosaurus and armored tanks like Antarctopelta showcase the extremes of survival, the Antarctic ecosystem was also home to smaller, more nimble dinosaurs. Also discovered on James Ross Island from the same late Cretaceous rock formations comes Trinisaura santamartaensis. This small ornithopod or bird-footed dinosaur reveals another successful strategy for life at the polar circle: social living. Trinisaura was a relatively small herbivore, measuring only about 5 feet in length. In a world populated by much larger animals, its size could have been a disadvantage. However, what it lacked in bulk, it likely made up for in numbers and agility. Paleontologists believe that Trinisaura, and other small ornithopods were social animals that lived and moved in herds or flocks, a behavior that is common in many modern prey animals. Living in a group would have offered significant advantages. More eyes meant a better chance of spotting an approaching predator, and a coordinated herd could confuse an attacker, allowing most members to escape. This social structure would have been especially beneficial in the low-light conditions of the polar winter, where a lone individual would be extremely vulnerable. It was a classic case of safety in numbers, adapted for a polar world. Intriguingly, the skull of Trinisaura shows it had particularly large eye sockets, or orbits. This anatomical feature suggests it had large eyes, which could have been an adaptation for improved vision in the dim twilight conditions of the long polar night. Being able to see well in the dark would have been a critical advantage for both finding food and avoiding becoming food during the challenging winter months for these dinosaurs. The presence of a small, fast and social herbivore like Trinisaura adds another layer of complexity to our understanding of Cretaceous Antarctica. It shows us that the continent supported a diverse fauna with multiple ecological niches. It was not just a land of titans, but also a home for smaller creatures that used intelligence, speed and cooperation to survive, all while being stalked by hunters that were themselves uniquely adapted to this environment. The cast of characters from late Cretaceous Antarctica is not complete without a fearsome predator. While Antarctopelta had its armor and Trinisaura had its herd, they needed protection from something. The evidence for this hunter comes from the Naze Peninsula of James Ross Island in the form of fragmentary remains, teeth and foot bones that hint at a truly terrifying creature lurking in the polar forests. Although these fossils are not complete enough to assign a formal scientific name, they bear the hallmarks of a specific group of theropods, the Megaraptorans. This group of dinosaurs, whose name means giant thieves, were not true raptors like Velociraptor, but were a distinct lineage of large carnivores known for their enormous, sickle-like claws, not on their feet, but on their hands. A Megaraptoran in Antarctica would have been a formidable predator. These dinosaurs were lightly built for their size, suggesting they were fast and agile hunters. Instead of relying on a powerful bite, their primary weapons were their massive hand claws, which could have been used to restrain and slash at prey. It would have been a specialized hunter, perfectly capable of tackling both the armored Antarctopelta and the nimble Trinisaura. This discovery highlights the vital importance of even incomplete fossils in paleontology. A single tooth or a piece of a bone can open a window into the past, allowing scientists to identify the types of animals present in an ecosystem. These fragments are the clues that help us reconstruct the intricate web of predator-prey relationships that defined this lost polar world and its unique dinosaurs. The unnamed Naze theropod adds an element of thrilling mystery to the story of Antarctic dinosaurs. It represents a ghost lineage, a predator we know was there but cannot yet fully picture. It serves as a powerful reminder that the continent's icy grip still holds many secrets. Each new fossil fragment chipped from the rock is another piece of the puzzle, slowly revealing the full and ferocious nature of life at the South Pole. The 5 species we have explored, Cryolophosaurus, Glacialosaurus, Antarctopelta, Trinisaura, and the Naze Megaraptoran, paint a vibrant picture of dinosaur life in Antarctica. But their existence raises a crucial question. How did they all manage to survive the single greatest challenge of their environment? The polar night, a period of continuous darkness and cold that lasted for months on end, was a test of ultimate endurance. One key to their survival may have been their physiology. A growing body of evidence suggests that many dinosaurs, particularly active predators like theropods, were warm-blooded or endothermic. This would have allowed them to maintain a constant internal body temperature and remain active even when external temperatures dropped. Furthermore, many dinosaurs had feathers, which would have provided excellent insulation against the polar chill. Behavioral adaptations were likely just as important. Some species, particularly large herbivores like Glacialosaurus, may have undergone long-distance seasonal migrations, moving to lower latitudes within Gondwana to follow the sunlight and available vegetation. Other dinosaurs may have stayed and adapted. The large eyes of Trinisaura suggest an ability to function in low light, while others might have entered a state of hibernation or reduced activity to conserve energy. The plants of polar forests also had to be resilient. They likely entered a dormant phase during the winter, similar to deciduous trees today. This would have created a winter of scarcity for herbivores, forcing them to switch to tougher food sources like bark, twigs, and evergreen needles, or rely on fat reserves built up during the bountiful summer months. This seasonal cycle would have dictated the rhythm of life for all Antarctic dinosaurs. Ultimately, there was no single strategy for survival. The diversity of dinosaur forms found in Antarctica reflects a diversity of solutions to the problem of the polar night. From the brute force of a large predator to the social cooperation of a small herbivore, these animals demonstrate the incredible evolutionary plasticity of the dinosaurs, which allowed them to conquer one of the most extreme environments the world has ever known. The world of the Antarctic dinosaurs, a realm of twilight forests and incredible resilience, was not to last forever. Like all other non-avian dinosaurs across the globe, their time came to an end 66 million years ago with the cataclysmic impact of the Chicxulub asteroid. This event triggered a global impact winter, plunging the entire planet into a period of prolonged darkness and cold that decimated ecosystems worldwide. This raises a fascinating and poignant question. Were the polar dinosaurs uniquely equipped to survive the apocalypse? Having already adapted to long periods of cold and dark, they may have been better prepared for the initial shock of the impact winter than their counterparts in tropical regions. It is a compelling hypothesis that for a brief time, these specialists in survival might have outlasted others, though ultimately they too succumbed to the collapse of the global food web. The legacy of these incredible animals is one of profound scientific importance. Their discovery completely transformed our understanding of the adaptability and global reach of dinosaurs. They were not simply lumbering reptiles confined to warm climates, but were a wildly successful and diverse group of animals that thrived in every environment on Earth, from arid deserts to the freezing polar twilight, a testament to their evolutionary mastery. Today, Antarctica remains one of the last great frontiers for paleontology. The continent is vast, and the areas of exposed rock where fossils can be found are minuscule and incredibly remote. We have only scratched the surface of this lost world. The ice still holds the remains of countless other species of dinosaurs and other prehistoric creatures that are waiting to be discovered by future generations of intrepid scientists. Each fossil painstakingly excavated from the frozen ground is more than just a bone. It is a story. It is a chapter in an epic tale of survival against the odds, of life's tenacity in the face of extreme adversity. The dinosaurs of Antarctica are a powerful reminder that even in the most desolate place on Earth, there was once a thriving, dynamic, and truly wondrous world.